Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 164, and today is our lesson number 93. Page 164, problem number 88. Let's take a look at it. It says the total cost to produce a batch of tools is $10,000 plus $300 per tool. So we have a total cost. Now listen, here's the deal. It is, after all, preparation for GMAT, Graduate Management Admission Test, because you want to get in the business school. Regardless of what your undergraduate background may be, there are some basic things, basic terminology that you have to know. Even if you take the undergraduate microeconomics course, principles of microeconomics, you would come across a concept of total cost being equal to the fixed cost plus the marginal cost. That's what we are dealing with here. We have a total cost which is made up of our fixed cost plus the marginal cost. Here we are told that we have a batch. We have a batch of 20,000. If you read the whole problem, it tells you later on in the problem that the batch consists of 20,000 units. They don't make it very clear, but that's what they mean there. And we are told that the batch of 20,000 costs $10,000 in fixed cost. This is your fixed cost. So as soon as you turn the machine on, it makes a batch of 20,000 units. That's the nature of the machine, and it costs $10,000 to run the machine just to turn it on. That's the fixed cost. In addition to that, it costs $3 per tool in marginal cost. It costs $3 per tool in additional cost. So perhaps the $10,000 that we're looking at is the license fee. Perhaps it's something that they're doing there where they have to pay $10,000 for the license fee, and they can produce up to 20,000 CDs or 20,000 discs or whatever it is. But to produce each CD, it costs additional $3 per unit. That's the idea. We're going to turn it around. We're going to turn around, we're going to sell it. We're not going to turn it around, that's not the expression. We're going to turn around, that's the expression, I believe. And we're going to sell it for, we're going to sell these units for $8 each. They express this thing in past tense, so that's what they say. They sold it for $8 per unit. The question simply is, what is the profit per unit? What is the profit per unit? Let's find out, shall we? So here's our fixed cost. Fixed cost, we are told, is $20,000. It should say $10,000. So we are making 20,000 units, and it costs a fixed amount of $10,000. That tells us that the fixed cost is 50 cents per unit. 50 cents per unit. They also tell us that the marginal cost is $3 per unit. I hope everybody who is watching is familiar with the concept of marginal cost, which is the cost, additional cost per unit as you start making it, which is typically the cost of the material. You may have a fixed cost, maybe the rent, maybe the license fee, as I said, or maybe some other fixed cost that you have, which is fixed regardless of how many you make in a batch. Even if you just make 2 units in a batch, it will still cost you $10,000 to run the so-called quote-unquote batch. but you can obviously, if it's going to cost you that much, you're going to run the entire batch, and the batch consists of 20,000 units. So if you're going to make 20,000 units and it's cost $10,000 for the batch, the fixed cost per unit is 50 cents. In addition to that, it costs $3 additional per unit, which is your marginal cost right here. Therefore, the total cost per unit is $3 of marginal cost plus 50 cents of fixed cost, or $3.50 per unit. That's your total cost per unit. We are selling it for $8. Selling it for $8. Therefore, the profit per unit must be $8 minus $3.50, which is $4.50 per unit. That's it. As always, I've done it again. I think I explained the bloody thing in too much of a detail. But anyway, that's what it is. You want to do one more? Let's do one more. Let's do one more. I'm going to erase the top part and we're going to start from the top. 89. In 89, they tell us that we can make 100 units. We can make 100 units for Q dollars. Well, if that's the case, then the cost per unit must be this 100 units for Q dollars, so it's Q dollars per 100. Q dollars per 100. This is the cost per unit. Then we have a 50% markup. 50% markup, we are told. The question is, what is the price per unit? Price per unit. Let's find out, shall we? Price per unit is going to be, because of the fact that there is a 50% markup, 50% markup means whatever this cost is times 1.5. The price is going to be whatever the cost is times 1.5. The 0.5 represents the 50% markup. So if it was a dollar, it's going to be $1.50. The price is going to be $1.50. If it was $3, the price is going to be $4.50. It's a 50% markup. Whatever the cost is, you take half of that, which is 0.5 of the cost, and therefore is 1.5 of the cost. 1.5 of the cost. Cost is right there. Q over 100 times 1.5. I don't know about you, but I don't like dealing with decimals, so I'm going to multiply the top and bottom by 10. So we end up with 1.5 times 10 is 15, so we end up with 15Q over 1000, because 10 times 100 is 1000. Now let's divide the top and bottom by 5. How many 5 in a 15? 15 has 3 5s. How many 5s in a 100? 100 has 25s. And then this 0 comes down and it becomes 200. So we end up with 3 over 200. That's our answer. 3 over 200 Q. 3 over 200 times Q. That's it. That's all it is. That's your answer. Now if you didn't like this algebraic way, another way we could have solved it. If you don't want to do it with the algebra, if you don't want to deal with this mumbo jumbo, another way we could have solved it is by plugging in numbers. So let's plug in numbers. It says 100 units for Q dollars. Now what we do in this method is to make up some nice number, which is where we can divide 100 into. For example, I'm not going to put in 3 here, because then we'll have to divide 3 over 100. I'm going to put in something that I can divide 100 very easily by. Let's put in 400. Let's pretend that Q is 400. So now it says that we're making 100 units for $400. If that's the case, that implies that it costs us $4 per unit is the cost. Since markup is 50%, that implies that the markup is 50% of $4 or $2. And therefore the price is going to be $6. This is what we call the punchline. Now this is plugging in method, you understand? That's the punchline. Now what we're going to do is, we're going to go through every single answer choices, and wherever we see Q, we're going to replace it with the number that we plugged in. You can plug in anything that you want, it's up to you. We could have plugged in 300 here, because 300 divides nicely into 100. We could have plugged in 900, but I would plug in some multiple of 100 here so that we can divide easily into 100. Like I said, 3 would not be a nice number to plug in, because in order to figure out the cost per unit, you will have to divide 3 by 100. That will be a nasty number. So I don't want to deal with that. So now all we have to do is go through all the answer choices. Whatever we see Q, we replace it with 400 until we hit upon answer choice that gives us our punchline, which is 6. Let's look at answer choice A. Answer choice A says, what does A say? What number was this problem? 89. 3Q over 200. 3Q, which is 400, over 200. Oh, what do you know? 4 divided by 2 is 2, and we get our 6. 3 times 2 is 6. There you go, that's your answer. It better be, because that was the answer when we did the algebraic way. That was the same answer, which was A. Answer obviously is not going to change. Answer also is not going to change just because you plug in different numbers. If it did, then this technique would be worthless. The answer is A. You want to do one more? Should we do one more or not? Let's leave it at that. Let's leave it here. I'll see you tomorrow, okay? Bye now.